All right, let's restart. So welcome to lecture 5. Today we're going to be talking about networking. So, quick recap of what we learned previously in the course, right? So we learned about at the beginning what Swift is, right? That was the first week. And the second week we learned about how we constrain things, so how we lay out things on the screen. And on the third week we learned about delegation and VC, and the idea is that now we take things away from just one screen, but we have multiple screens, right? And we learn how to pass information from screen to screen. Then after that, we learned about table views. That's the first introduction of a what we call a UI scroll view. The idea is you can display lots of data on one screen, and Swift kind of helps you out. Sorry, iOS kind of helps you out, right? They give you a UI kit gives you this thing called a UI table view, and you set some stuff up, and you can display things in terms of rows. And then last week, oh wait, there should be lecture 6, huh?
Yeah.
Okay, whatever. I already started. Anyways, that's gonna be 6. But last week, which is week 5, we learned about collection views, right? We learned about kind of a more powerful version of table views, arguably. You have different flow layouts, things can look like cells, it's very pretty. And this week we're gonna kind of step away from all like the visual things, right? Surely you guys have learned a lot about that. But now let's talk more about how to make your apps more functional, right? How to kind of have it handle more data, have it able to process more things. And we do that through networking. Lecture 6, not 5. All right. So a few announcements first. We pushed back P5's deadline because Halloween. So it's due tomorrow. Late deadline is on Thursday. So normal deadline +2. And we're going to highlight some very cool submissions. So, okay. Let's... Oh, wait, actually, I think I have names here. All right, so these are some of the submissions, right? If your name's on here, congrats. But the idea is that let's have a quick look at what these are, right? So the first one is this one. I think this is ACT 238. So that's Antoinette. And this is pretty cool, right? You see all the features are here. And what I really like is the images here, right? There's a little bit of issue with the way things are constrained because it's a little overflowing, but that's fine, right? We can fix that later. But overall, a very functional app and looks very nice. All right, cool. And then next, let's look at the second one. So very, very pretty. And you can look at some art. It's very nice. And you set your name here. Say my name is Elvis. And I can put that happy birthday, right? That's very nice, very functional. It's like fulfills the requirements, right? But it does it really well, right? And makes things look very pretty. So I like that. All right. And so this one is it doesn't look as kind of stunning, but has a lot of features that some of these are also extra credit. So first, this date picker thing was I don't know why my phone's in Korean. But it's a date picker, right? That means month, that means day, right? Okay, Korean taught me something. But the idea is, they have a date picker, right? And this, this is given to you, right? This thing called a UI date picker. And you kind of just oops. Something up. That was bound to happen someday. Okay, so the recording's still going, right? No, it has to do with my phone. Yeah. Okay, so you can pick a day, right? And that looks really cool, right? There's this wheel, but this is really easy to set up if you kind of go through the documentation and figure that out. But it's the power of frameworks, right? You figure out how to use it, and you don't have to write a whole lot of code yourself. All right, and another thing is if you kind of actually add an event. So say this is intro to iOS. Class start time is 8:40 p.m. All right, let's keep going. And event link is www.google. Oh no, https://google. No, google.com. We add it. Okay, I messed something up. Oh, this is one. Sorry, I'm kind of butchering your app. All right, cool. And if I click on this, it actually opens the site, right? So it's really cool. And of course, I just did Google, right? But you actually can link it to Zoom link, and it's pretty functional, right? So that's from Jason. Very nice. Yeah, exactly. It's also ordered, right? Very nice. Cool. And the final submission is from, I forgot the name, sorry, Rainy. I think that's how I pronounce it, hopefully. But again, very, very pretty app. But I think a really nice touch is, when you select on it, right, you see this white border to kind of show selection, right? I think a lot of the what makes a good app from a great app is like the attention to detail, and over here there's like a small touch of kind of like feedback for user selection is, I think, what it really makes it sets it apart. And also I like the dark theme, it's pretty cool, and all the stuff's there, right? So cool. Again, every lecture we're gonna now try to like highlight great submissions from the past week. And if you kind of put a lot of effort into the projects, we want to kind of shout you out for that. And hopefully not only you learned a lot, but had a lot of fun. Cool. All right. So now moving into the bulk of today's lecture. Today we're talking about networking. So today's lecture is going to be split into 4 sections. First, we're going to talk about what networking is generally, and then we'll talk about how networking is done, specifically through HTTP requests. Then we're going to talk a bit about more specifically the HTTP response codes. So when you send a request, what happens, right? And then finally, we'll be talking about what a JSON is. And a sneak peek idea is JSON is kind of a way that we use to kind of do this communication. All right, so first, networking. So the idea of networking, it's not like a bunch of people wearing suits, right? At like some mixer. No, right? In the context of this course, networking is basically connecting your app to the internet. And, why do we want to do this, right? So let's look at a quick example here. So these apps, hopefully you've used them before, or at least one of them before, right? I mean, I'm sure you've used Google before. How do these work, right? So let's look at a quick example. So over here we have Facebook, we have Gmail, we have Google. So let's pick like Gmail, for example. Now surely after I've done doing 4 or 5 projects, you have a rough idea, if I show you this screen, how you would want to go around implementing it, right? So, I see emails here. We probably want to create a class to represent that email, right? Has some fields like a title, some content. Maybe you see how there's like a star on the side. So maybe you have a Boolean, right? Saying whether or not an email is starred. And visually, how maybe we will use kind of a table view, right? Because they're appearing in rows, right? So that's cool and all, right? But one thing you surely have like a lot of experience with in the past projects is when you're creating your data, often what happens is you just kind of write it once, you copy and paste it 5 times, and then you change it a little bit, and you're like, here's my data, right? But what if you need more? You go back and copy and paste it more, and it can get quite, bulky, right? It can get pretty cluttered in your files, and you just end up submitting like 50 lines of just kind of copy and pasted data, right? So real apps in the real world don't do that, right? And surely the emails that you see on your app aren't just the same emails copy and pasted over and over again. So how do we get these emails, right? How do we get this data? And, like only after we get it, can we display it, right? And, oh, sorry, I skipped a slide, but the idea is, this is like how you would display it visually, right? So right now, previously, we've been kind of defining everything manually, right? You just define a variable, put in some properties, that's your data. And one other issue is that, say you kind of make a typo, right? And you have to go back, right? Go back and change everything. And it just requires a lot of manual tending. So the solution to this is networking, right? Instead of having you as the app developer define all the data, as well as kind of just like set up all the testing stuff with respect to the data, what you can do is to have someone else deal with that, right? And the idea is that, when you have this kind of separation between the front end and the back end, the idea is that you provide kind of the front end functionality, right? What happens when the user interacts with the app. And all you have to do when you want data is you kind of query, or you ask for the data from somewhere else, and they send that data to you. And based on what they send you, you display that, right? So that kind of solves the issue of you having to define all the data yourself. Okay, so how do we do that, right? How do we set up this communication between your app and some other mysterious party across the internet, right? So let's first talk about what an HTTP request is. Okay, so the HTTP request is one of many ways we kind of do this communication, right? There are a lot of other ways of kind of doing communication, right? But HTTPS is 1, the most common, and 2, the most simple. So we're going to be talking about this. And in terms of mobile development, this is used the most frequently. Okay, so HTTPS basically works along a client and server model. And so what that means is that you have a client, and in the context of iOS development, that's your phone, right? The app you're developing, that's the client. And the server is just some other computing device somewhere, right? In fact, the client can be your phone, right? The app you're kind of working on, and the server could be someone else's app, right? It doesn't have to be like a computer, right? It doesn't have to be this kind of stereotypical big like computing center of like thousands and thousands of like these computing hardware. It could just be someone else's phone, right? But that doesn't really concern you. All you really have to know is the client is your app, right? Your phone, your app, and the server is some other party that has the ability to do some computing. Okay. So the way this communication works, right? There are two steps, and the order matters. So first, the client, oh, I forgot to put the tag, but the client being your phone makes a request, right? So an example would be, in terms of Gmail, give me my emails, right? And based on the request, the server would respond, right? The server would then be like, okay, sure, here's your emails. So the client requests, the server responds, okay? And the reason why I'm stressing this is that, this is pretty like, it's a very simple concept at first, but a lot of the times when you actually try to implement something, right, you have a lot of these ideas, and a lot of the times, like, you can't forget this. So a key example is, say, push notifications, right? So previously in the hack challenge, someone was like, oh, I want to make push notifications. How would that work? Well, I'm going to have my server tell my phone when to display something, right? But you see how that kind of violates this client server protocol, model, right? Because if you want the server to tell the client what to do, it's no longer the client doing the requesting, right? You're kind of having the server push information to the client. And like, of course you can still do that, right? Push notifications is a thing. It's just not done through HTTP requests. Okay. All right. So just to recap, we have the internet. The internet is just a bunch of computing devices that can communicate with each other. Clients is basically kind of the devices that we're talking about or working on. And what they do is they call upon other services, right? They're requesting the information. And these servers are kind of the ones that respond, right? They're like, okay, you ask me for something based on how you ask, if you ask nicely, then I'll give it to you, okay? All right, so before we talk about the structure of a HTTP request, right, and like what types of HTTP requests there are, let's first take a little bit of a detour and talk about URLs, otherwise known as the Uniform Resource Locator. So this is basically what an URL is. It's very long, but there are only like a few key things you want to pay attention to, right? So first, this is called the scheme, right? It's HTTP or it could be HTTPS. The S stands for secure. Most modern kind of sites use HTTPS because I think it's required actually for Safari. But the idea is that you don't really have to care about this, right? It's just there. What matters though is this is what we call a domain. So the domain is kind of like when someone says, oh, I have like a website, right? www.justinai.com, right? Okay, that's not my website. Someone else took that domain from me. But anyways, the domain is kind of like where your site is, right? I like to make this analogy of kind of like a mailing address, right? So the domain name would kind of just be your street number, right? Or like this is the street, right? Not the number just yet. So for example, my domain name would be College Avenue, right? Because I live in College Avenue. All right. The next part is the port. So the port is basically, after you have the domain, right? Say for example, the domain is your computer, right? Which is localhost. And you want to be able to do multiple things at once, right? You don't want to just be like, oh, if one party is communicating to my computer, I have to like finish talking to them before I can talk to someone else, right? You want to be able to multitask. And the reason and the way to support that is by having multiple ports, right? And that's similar to how a street can have multiple street numbers, right? You can have like 101 College Avenue, you can have 102 College Avenue, you can have 103 College Avenue, and they're all different houses, right? They're not all the same house, right? Even though they're all on the same street. So that's the idea of a port. And then, you can have like more specifically, right? After you have the port, you can be like, oh, like which room am I? If you have roommates, right? I'm talking about this really abstractly because you don't really have to care too much about this, right? Maybe if you go more into like web development and like if you're setting up that kind of stuff, maybe you'll have to think more about this. But for all use cases and purposes, I just want to get you guys familiar with what a URL is and the components of it, right? Okay. And the more important part is this. So this is called a parameter. And the idea is that when you kind of go to a URL, or we talk about the analogy of a kind of like a mailing address, you go to a place, right? Say for example, you're visiting your friend, you can go bearing gifts, right? Or you can come bearing bad news of your assignment due tonight, right? Like you can bear different things. And the idea of kind of appearing or going to your friend's doorstep with different things is mirrored with the idea of parameters, right? So say, for example, you're requesting information from Google. In fact, you can try that later, type a Google search and look at the URL, right? You'll see something as like a question mark and Q and equals, and then your query is there, right? So we'll talk more about this later when we talk about GET requests, but the idea is that this parameter is where you specify what information you want or kind of what you want to do when you request from the backend. And finally, the anchor is, forgot about it, but the anchor is like, for example, you go to the same spot on the page, we want to go to like a specific part, right? There are these A tag anchors, but we don't really care about this. All right, so we talked about URLs. Right now, let's go back to HTTP requests, right? So just to recap, the HTTP request is a way we communicate from the client to the server, okay? It's a way we communicate. And there are multiple ways we can do this communication, right? There are multiple types. There's a GET request, there's the POST request, there's the DELETE request, and there's a lot more, right? But for all use cases and purposes, these GET, POST, and DELETE you'll be using 99% of the time. You don't really have to worry about the rest. In fact, GET and POST you'll be using most of the time. You rarely would use DELETE and rarely will use the rest, which is why I'm just not even putting it there. But if you're curious, you can Google it. There's a lot more. And yeah, cool. So let's go through what each of these do one by one. So the GET request is mostly used to retrieve some information from the server, right? So for example, get my emails, right? So that's what you would do with a GET request. POST request, on the other hand, is you kind of sending information, right? And there's actually like, if you go to the textbook, like the actual course textbook and go to like the networking section, I talk a little bit more about specifically like, why we would use a POST request as opposed to a GET request, even if we were trying to get information, right? But for most general use cases, POST is used to send information. And the reason why is because with a POST request, not only can you kind of specify things in the parameter or in the URL, but you can also send like chunks of information, right? You can send a JSON, you can send a file, which kind of is compressed down into JSON, and you can send other stuff, right? And we'll go into a lot more detail on how you want to be sending this parcel of information in the demo this Wednesday. But for now, GET request is to retrieve information. POST request is to send information. And finally, as you guessed it, DELETE request is you're telling the server, that photo that I took 20 years ago, right? Delete that, please, right? That's a DELETE request. And the idea is you're sending something, you're sending a request to the backend, to the server, for them to do something internally, okay? And there are other ones for other purposes. You can read about that in your own time, but the first two are probably all you really need for this course, okay? All right, so just a quick little mention of this. This is called the CRUD paradigm, or I think I said here, the CRUD, right? And it stands for create, retrieve, update, and delete. We don't really concern ourselves too much about this paradigm, but if you do take the backend course, they talk a lot more about this. The idea is that you want to be able to support all different types of things when you are working with a piece of data. So for example, if I have a Spotify, right? In Spotify, I can create a playlist, I can add songs to the playlist, right? I can get information about my playlist, and I can delete the playlist, right? That kind of corresponds with the CRUD paradigm. And in order to let kind of someone's app do that, right? Because surely you can do that on the Spotify app, you must have kind of requests or endpoints that correspond to that, okay? We don't care too much about this, but I just wanted to let you guys know that this paradigm is something that people think about when they're kind of setting up backends, as well as when you're sending your queries, specifically what you are doing, okay? All right, so CRUD. All right, what is the slide here for? Oh, yes, I want to recap the request and response paradigm. All right, so we talked about, why is it going backwards? Huh? Sorry, the computer was lagging. All right, so we send a request, right? And in doing this request, we send a GET request, a POST request, a DELETE request, some other requests, right? Trying to do something. So that's enough about the client side, right? Like what happens from your phone / your app. But after we send the request, the server is going to respond. Now, what happens when the server responds, right? So now I want to talk a little about what happens. And now we're going to talk about this thing called a HTTP response code. So basically, when the server responds, right, it's going to send you some information or no information, right? But what it will always send you is this response code. And this response code is a 3-digit code that tells you basically or summarizes what happened, right? Because, for example, like if you're requesting for, all the Cornell students' social security numbers, right? Like, an endpoint shouldn't just give everyone that information, right? So, it reserves the right to say no, right? And like, how do you know that like they responded you no and said you nothing, or if there just are no students in Cornell, right? So you need to be able to differentiate that. And the response code kind of differentiates all the different scenarios that could happen, right? Because it could be like, there could be other more complex things. So the response code is kind of splits up into two parts, right? There's the category, which is the first digit, and there's the code, which is the next 2 digits. So let's first talk about the category, right? The category is a number from 1 to 5, and it basically, I mean, as you can just see, right? If you get a 1 something something, it's informational, right? So you can just forget about it because usually it's just like, oh, this endpoint is very old, like that kind of thing, right? So you can forget about that. That's not very important. 2 something something is something you always want to see, right? That means you succeeded. Good job, right? 200 is usually the one is like response is okay, right? That's like the good job one. 300 is a redirection, but usually that means it's still fine, right? The idea is, say, for example, you're trying to go to Facebook, but Facebook is like, haha, no, I'm Meta now. So if you type in Facebook and they redirect you to Meta, right, sure, like you'll still be able to access the site, but, it will get a 300, right? Because they're kind of redirecting you to the new address, right? All right. Now, 4 and 5 is what you don't want to see, right? That means something went wrong. But for the good news is that if you see a 500 error, chances are it's not your problem, right? Because you're the one who's building the app, ideally building the client. So if you see a 500 error, ideally if you're working in the hack challenge, you're like, take a screenshot and like, backend member, this is your problem, right? But if you see a 400 error, then yes, that's your problem, right? So let's talk more about the 400 error because that's the error that you'll be dealing with mostly in the iOS course. And yes, so the 400 client error, there's like a lot, right? There's like a lot more. You can Google that yourself. But specifically, when you see a 4 something something, right, you can look at the something something, the next 2 digits, to specifically narrow down what the issue is, right? So for example, bad request probably means that, the endpoint requires a parameter, you didn't send it the parameter, right? Some easy fix. Unauthorized, for example, is it's asking for a password, right? Or maybe it's asking for a session cookie, and you don't have that, right? No. And so going back to the example of getting all the Cornell students' social security numbers, right? You probably need to be authorized to do that. So if any average Joe decides to send a request across, it's probably going to respond with a 401, right? Because they don't have access, unauthorized, right? And there's a lot more, right? Say for example, you're building like a site or like an app that's like paid service, and then someone else tries to access it. If they haven't paid, then payment required, right? So there's a lot more other narrow cases. But as you start kind of working and implementing networking in your apps, you'll get more familiar with it. And as you face more errors, you'll learn about what these error codes actually are. Okay, cool. Yes. So kind of moving away from the client error codes, these are just the more common ones, right? So 200 is okay. 301 means moved permanently. That means like, for example, you're going to like facebook.com, but they're permanently renamed to Meta, then facebook.com no longer exists, for example, right? I don't know if it does, but whatever. Okay. And 403 is forbidden, so you try to access something, but you're not allowed to, right? And 404, probably the most common one is something is no longer found. So you're accessing a website and it was deleted, right? Not even redirected. 410 is gone. 500 is internal server error. This is the one where you'd be like, yay, right? Not my problem. But yeah, anyways, so that is one that basically saying that the server has an issue, right? Remember the server and client kind of separation. The client is your phone. The server is someone else's computing device. Okay. Cool. So we talked about the response code, right? And I actually skipped over like what happens with the actual response and how we decode that, because that is the content of next week's lecture, where we actually show you how to use this thing called a Lamofier to actually, 1, send the requests, and 2, parse the requests. That's a little more involved, so we're going to split it off into a separate lecture. But yeah, so today's lecture is just to go over the high-level concept, right? 1, what a request is. 2, what happens in the response, and kind of like what networking is in general. Okay. So one final thing I want to talk about is the idea of a JSON. So I talked about how the client kind of sends a request, right? And I talked about how the server can give you a response code, right? But one very important idea is they need to be able to have some standardized way of communicating, right? Which goes back to the question from the previous slide: how do we communicate with the server, right? Because if they send me like every time they send me something, it's all of a different format. I don't know how to parse it. I have to try different ways. Like, that's not going to be okay, right? So one way we standardize this communication is using this thing called a JSON. And a JSON is just a format of a file, basically, or format of a data that basically is very like systematic, right? You can think of it as like a Python dictionary, for example. And the idea is you have a key, and corresponding to that key is some value, right? And basically the keys, these are just like some small niche things with respect to the way a JSON is structured. So the keys always have to be a string, and the values can be anything. So like a string, an object, an integer, a boolean, an array, or like null, for example. And the idea here is that if the server always sends you back something of the form of a JSON, then every single time when you receive a response, you can just assume that it is a JSON and you parse it accordingly, right? That makes everyone's life easier. So that's how most things are done nowadays. Okay, so this is an example of a JSON, right? So you see how these keys are all strings, and like the value corresponding could be anything, right? Anything in the sense that it could be a string, it could be an integer, it could be an array, it could be an array of more JSONs, right? That's how you have like really complex JSONs. They're like nested, right? And you can also have a null, but I don't think I displayed it here. But you can have a null, and you can also have if you define like a custom class, you can also put that in there as well. Okay, cool. So, okay, that's actually all for today's lecture. That's pretty fast. So next week, actually no, sorry, this Wednesday, we'll show a little bit about kind of setting up some stuff that you need. But for next week, we will be talking about the bulk of how you, one, like actually set up the setting of the request, and two, processing the response, right? That's probably the more important part. And hopefully this gave you a good enough of a high level overview of what we're going to be doing, right? The idea is just, when you want to be able to add more functionality to your app, right? Not just have everything be local, you need to introduce networking, right? Be able to communicate with other apps. And the way you do that is kind of with this HTTP request, or these HTTP like communication protocol. And, 3 types of HTTP requests. And after you send a request, you get a response. Okay, I think I did enough summarizing. Let's move on to the Kahoot.